September 17, 1944. The afternoon light filtered through broken clouds above the Dutch coast near Walcheren Island. Hauptmann Georg Richter of the Wehrmacht's Coastal Defense Engineering Battalion watched through his field glasses as Allied landing craft approached the shoreline. What caught his attention wasn't the craft themselves, he'd seen hundreds during the Normandy fighting, but what emerged from them. Vehicles were driving directly out of the water onto the beach, not being unloaded by crane or ramp, but simply motoring from sea to land, as if the boundary between elements meant nothing at all. These weren't amphibious tanks, which the Germans knew well. These were trucks, full-sized cargo trucks carrying supplies, towing artillery pieces, loaded with troops, driving through surf that should have drowned their engines and climbing onto sand without pausing. Richter had spent 3 years studying Allied equipment, writing technical assessments for Wehrmacht intelligence. He'd examined American half-tracks, British armoured cars, Canadian tanks, but this was something entirely new, a vehicle that challenged fundamental assumptions about what wheeled transport could accomplish. Within hours, his unit would capture one of these machines intact. What German engineers discovered over the following weeks would force them to confront uncomfortable truths about American industrial ingenuity and Germany's failure to develop equivalent capability. The vehicle bore the designation DUKW. American soldiers called it simply the Duck. It would prove to be one of the most revolutionary logistics vehicles of the war, embodying an engineering approach Germany had never attempted and could never replicate. The vehicle Richter's men captured that evening sat abandoned near a destroyed bridge, its crew having withdrawn under artillery fire. Unlike most American equipment left behind in hasty retreats, this one was completely intact. The Germans approached cautiously, watching for demolition charges or booby traps. They found neither. The crew had simply driven it as far as the broken bridge allowed, then evacuated on foot when their position became untenable. Obergefreiter Klaus Weber, the unit's senior mechanic, climbed into the driver's compartment. At first glance, it appeared to be a standard American truck, similar to the GMC 2.5-ton vehicles the Wehrmacht had encountered throughout France. The cab layout was familiar: steering wheel, instrument panel, gear shift, but additional controls immediately caught Weber's attention. A second shift, lever-labeled transfer case, a propellet engagement lever, a tyre pressure control system with gauges for all 6 wheels, and a bilge pump switch. The bed behind the cab was open, designed to carry cargo, but instead of a solid floor, Weber found drainage ports and a hull design clearly intended for water operations. The entire vehicle was essentially a boat with wheels, or perhaps more accurately, a truck with a hull. The engineering implications were staggering. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Weber called over his commanding officer. Herr Hauptmann, this vehicle is designed to operate both on land and in water. It's not an adaptation of existing equipment. It appears purpose-built for amphibious operations. Richter examined the machine more carefully. The body was constructed from welded steel plate forming a watertight hull. The rear housed a propeller assembly connected to the engine via drive shaft. The wheels could be driven independently or disengaged when operating on water. Most remarkably, the tire inflation system allowed the driver to adjust pressure while moving, optimizing traction for different terrain, fully inflated for roads, partially deflated for soft sand or mud. This wasn't a battlefield improvisation. This was a sophisticated engineering solution to a problem the Wehrmacht had barely acknowledged existed. Germany possessed amphibious vehicles, the Schwimmwagen for light reconnaissance, experimental amphibious tanks for river crossings. But Germany had never developed a true amphibious cargo vehicle capable of transporting supplies directly from ship to shore, bypassing damaged ports and inadequate harbours. The unit's engineers spent the remainder of that evening conducting a preliminary inspection. They measured dimensions 31 feet long, 8 feet wide, weighing approximately 15,000 pounds empty. The cargo capacity was listed on a placard as 5,000 pounds or 25 fully equipped soldiers. The engine was a GMC straight 6 producing 91 horsepower, the same reliable engine used in standard GMC trucks throughout the American military. What impressed the German engineers wasn't any single component's sophistication. The engine was competent but unremarkable. The transmission was straightforward. The construction was utilitarian rather than elegant. What impressed them was the integration. Every element worked together to solve a specific problem. How to transport cargo from ships offshore directly to inland positions without requiring functioning port facilities. The strategic implications were immediately apparent to Hauptmann Richter. The Allies could land supplies anywhere along a coastline, not just at ports. Destroyed harbours became irrelevant. Coastal defense could be bypassed. Traditional naval logistics assumed ships required harbours with cranes, warehouse, and rail connections. This vehicle eliminated those requirements entirely. Ships could anchor offshore beyond artillery range, load DUKWs with supplies, and send them directly to the front. The entire Allied invasion strategy suddenly made more sense. Over the following 3 days, Weber and his team conducted more thorough examinations. They traced electrical systems, mapped hydraulic lines, documented control mechanisms. The DUKW revealed itself to be deceptively sophisticated. The tire inflation system used onboard air compressors, allowing the driver to adjust all 6 tires from the cab while moving. In soft sand, reducing tire pressure from 35 pounds to 15 pounds per square inch increased the contact patch dramatically, preventing the vehicle from becoming mired. The propeller could be engaged or disengaged via a lever in the cab. In water, the propeller provided forward thrust, while the front wheels could be turned for steering. On land, the propeller disengaged completely, eliminating drag. The transition from water to land operations required no routine stopping, no reconfiguration, no crew action beyond shifting a lever. An experienced operator could drive from deep water onto a beach and up an inland road without interruption. The bilge pump system caught particular attention. Any vehicle operating in water risked taking on water through hatches, doors, or battle damage. The DUKW's automatic bilge pump system continuously removed water from the hull, maintaining buoyancy even if the vehicle sustained damage. German engineers calculated that the DUKW could remain operational with hull penetrations that would sink conventional boats. Most impressively, the vehicle appeared designed with crew survivability as a priority. Multiple escape hatches provided emergency exits. The hull design included buoyancy chambers, ensuring the vehicle would float even if partially flooded. Life preservers were stored in accessible compartments. The cab provided protection from small arms fire while maintaining excellent visibility. Everything suggested American designers had thoughtfully considered not just nominal operations, but also failure modes and emergency scenarios. By September 20th, the captured DUKW had been transported to a Wehrmacht coastal testing facility near Den Helder in the occupied Netherlands. Senior engineering officers arrived from Berlin to observe trials. The vehicle was fueled, basic maintenance was performed, and test crews prepared to evaluate its capabilities. The first water trial began at 0900 hours on September 22nd. A Wehrmacht driver, trained on standard trucks but with no amphibious experience, was instructed to drive the DUKW into the harbour. According to his later report, the experience was disconcerting but straightforward. He simply drove down a boat ramp as if entering a river ford. As the water deepened past the wheel hubs, the vehicle's buoyancy became apparent. The wheels lost traction as the hull began floating. He engaged the propeller drive, and the DUKW continued forward smoothly, now operating as a boat. Steering required adjustment. The front wheels turned in water, but the effect was sluggish compared to land operations. The propeller provided adequate forward thrust of approximately 6 knots, faster than rowing but slower than purpose-built boats. Maneuverability was acceptable for a vehicle of this size and weight. The driver reported feeling stable and secure, with no sense that the vehicle might capsize or founder. After 20 minutes operating in the harbour, he drove toward shore. As the wheels contacted the bottom in shallow water, he disengaged the propeller and applied power to the wheels. The DUKW transitioned from floating to driving without drama or difficulty. It climbed out of the water, across the beach, and up the access road exactly as a standard truck would operate. The entire demonstration, from entering the water to returning to land, required approximately 40 minutes and revealed no significant problems. Oberst Heinrich Schäfer, a senior logistics officer who had served in the invasion of France and later in Russia, observed the trial with growing concern. His report, which would reach Wehrmacht High Command within days, articulated what many German officers were beginning to understand. The American DUKW represents a fundamental rethinking of amphibious logistics, where we have focused on securing ports and establishing traditional supply lines. The Americans have developed capability to bypass ports entirely. This vehicle allows them to land supplies directly on any beach, in any weather, without requiring specialized facilities. The strategic advantage this provides cannot be overstated. Our coastal defense doctrine assumes the enemy requires functioning harbors. This vehicle makes that assumption obsolete. The testing continued for another week. Engineers subjected the DUKW to increasingly challenging conditions. They loaded it with maximum cargo and observed how it handled the weight. They drove it through heavy surf to test stability. They operated it in shallow water, where the wheels contacted bottom intermittently. They tested tire pressure adjustments on various terrain types. They measured fuel consumption, speed on land and water, turning radius, and obstacle crossing ability. The DUKW performed consistently well across all trials. It wasn't exceptional in any single category. It was slower on roads than standard trucks, slower in water than boats, less maneuverable than smaller vehicles, but it was adequate in all conditions, and that adequacy was revolutionary. No other vehicle could match its amphibious cargo capacity. Nothing else combined boat-like water operations with truck-like land mobility. German engineers calculated production complexity. The DUKW used a standard GMC truck chassis as its foundation, sharing components with hundreds of thousands of other vehicles in the American inventory. The hull was simple welded steel construction using techniques familiar to any shipyard or heavy manufacturing facility. The propeller system employed commercial marine components. The tire inflation system used standard compressed air technology. Nothing about the DUKW required exotic materials, specialized manufacturing, or revolutionary innovations. This was the pattern German engineers had observed repeatedly when examining American equipment. The Americans didn't pursue technical perfection, they pursued practical effectiveness using proven technologies. They designed vehicles that could be manufactured by existing industrial facilities using available materials and assembled by workers with moderate skills. Then they produced those vehicles in quantities that overwhelmed any technical advantages German equipment might possess. Lieutenant Friedrich Neumann, a young engineering officer who had studied mechanical engineering at Technical University of Berlin before the war, spent several days analyzing the DUKW in detail. His written assessment captured the fundamental challenge Germany faced. This vehicle could have been built by Germany. We possess the technical knowledge, the engineering expertise, the manufacturing capability. Yet we never developed anything equivalent. The question is, why? The answer reveals uncomfortable truths about German military thinking and industrial priorities. Neumann continued his analysis, documenting what he saw as German failures in innovation. We focused on perfecting existing vehicle categories, better tanks, faster aircraft, more powerful artillery. We rarely asked whether entirely new categories might be needed. The Americans identified a specific problem: how to sustain forces after amphibious landings without depending on ports, and designed a vehicle specifically to solve that problem. We never asked that question, so we never developed this answer. His report went further, addressing systemic issues. Germany's industrial capacity is constrained by material shortages, bombed factories, and labor limitations. We cannot afford to develop new vehicle types when existing programs demand all available resources. America faced no such constraints. They develop specialized vehicles for specific purposes: amphibious trucks for beach logistics, tracked landing vehicles for assault waves, wheeled cargo carriers for inland supply. Each vehicle optimized for its role. We build general-purpose vehicles and improvise when they prove inadequate. The testing facility near Den Helder became a hub of activity through late September and early October of 1944. Additional captured DUKWs arrived from various fronts, one from the Netherlands, two from France, another from Italy, where Allied forces had used them extensively during river crossings and coastal operations. Each vehicle was thoroughly documented, photographed, and tested. German engineers compiled data that would fill hundreds of pages in technical reports. What emerged from this comprehensive analysis was a picture of American logistics thinking that differed fundamentally from German doctrine. The Wehrmacht had always viewed logistics as a secondary concern, something to be addressed after tactical and strategic planning. Supply lines were expected to follow advancing armies using captured enemy infrastructure and stockpiled supplies. This approach had worked adequately in Poland and France, where campaigns concluded quickly. It had failed catastrophically in Russia, where distances proved vast, infrastructure inadequate, and resistance prolonged. The Americans approached logistics as a primary strategic consideration. They assumed they would need to sustain operations far from home across oceans, requiring vast quantities of supplies delivered reliably over months or years. The DUKW was one element of a comprehensive system designed to solve that challenge. It wasn't an isolated innovation, but part of an integrated logistics architecture that included Liberty ships for ocean transport, LSTs for beach landings, trucks for inland distribution, and infrastructure for supply management. Hauptmann Richter received permission to conduct extended operational trials. His unit used captured DUKWs for their own logistics, transporting supplies from ships anchored offshore to forward positions. The vehicles proved remarkably effective. German soldiers quickly learned to operate them despite having no formal training. The controls were intuitive, the maintenance requirements minimal, and the reliability excellent. One particular trial in early October demonstrated capabilities that astonished German observers. A DUKW was loaded with 4,000 pounds of ammunition and driven into moderately rough seas, with waves reaching 3 to 4 feet. The vehicle handled the conditions without difficulty, maintaining forward progress and remaining stable despite the motion. It reached a ship anchored 2 kilometers offshore, was loaded with additional supplies using the ship's crane, then returned to shore and drove directly to an inland ammunition depot 15 kilometers away. The entire operation required 4 hours and demonstrated end-to-end logistics capability German force simply didn't possess. Oberst Schäfer compiled a comprehensive report for Wehrmacht Logistics Command. He included detailed technical specifications, operational trial results, and strategic assessments. His conclusions were damning regarding German logistics capabilities. We have no equivalent to the DUKW and no capacity to develop one during wartime. Our amphibious vehicles are limited to light reconnaissance. The Schwimmwagen carries 4 soldiers and light equipment. We have experimental amphibious tanks for river crossings, but nothing designed for sustained cargo transport. The Americans can land 30 tons of supplies per hour on any beach using 10 DUKWs. We require functioning ports with cranes and rail connections. This disparity explains why Allied forces advance consistently while our forces struggle with supply shortages, even in static defense. The report reached Berlin in mid-October. Albert Speer's Armaments Ministry reviewed it alongside similar assessments of other captured American equipment. The pattern was consistent and troubling. American vehicles weren't necessarily superior in individual performance metrics, but they were better designed for wartime logistics. They emphasized reliability, ease of manufacture, component commonality, and operational flexibility. German vehicles emphasized performance, technical sophistication, and battlefield capability, while sacrificing logistical practicality. Several German engineering firms were tasked with assessing whether Germany could develop DUKW equivalents. Büssing Nag, which produced trucks for the Wehrmacht, submitted a preliminary design study in November. Their conclusion was pessimistic. Germany could theoretically design an amphibious truck, but production would require dedicated facilities, specialized components, and materials already allocated to higher priority programs. Even if production began immediately, first deliveries wouldn't occur before mid-1946, far too late to affect the war's outcome. The existing industrial base was fully committed to tanks, aircraft, submarines, and rockets. No capacity remained for new vehicle categories, regardless of their potential value. This represented a fundamental difference between American and German industrial approaches. American industry had sufficient capacity to pursue multiple parallel development programs. Ford could produce bombers while also manufacturing jeeps. General Motors could build tanks while simultaneously producing trucks and amphibious vehicles. American factories operated multiple shifts, employed millions of workers, and accessed global raw material supplies. German industry operated under severe constraint, bombed factories, material shortages, labor scarcities, and transportation bottlenecks. Germany was forced to prioritize ruthlessly, focusing resources on weapons deemed most critical, while abandoning potentially valuable but lower priority projects. The DUKW development history, which German intelligence eventually pieced together from captured documents and interrogated prisoners, revealed the American approach to military innovation. The vehicle had been designed in 1942 by Sparkman and Stephens, a yacht design firm working with General Motors. The initial concept emerged from observing Coast Guard problems rescuing crews from ships grounded on sandbars. Existing boats couldn't operate in shallow water, and trucks couldn't reach vessels offshore. An amphibious vehicle could bridge that gap. The military potential was immediately recognized. The Office of Strategic Services and Army Corps of Engineers supported development. A prototype was built in 38 days using a standard GMC truck chassis and a boat hull designed specifically for it. Testing occurred in June of 1942. By August, the vehicle was in production. First combat use occurred during Operation Torch, the invasion of North Africa in November 1942, just 5 months from initial prototype to combat deployment. This timeline astonished German engineers. Germany's development processes typically required years from concept to production. The Panther tank, for instance, had been conceived in 1941 in response to encountering Soviet 34 tanks, but didn't enter combat until mid-1943, a 2-year development cycle. German thoroughness demanded extensive testing, refinement, and perfection before accepting designs for production. The Americans apparently accepted adequate performance immediately and refined designs through production experience. The DUKW had been continuously improved during manufacturing. Early models had problems with propeller engagement mechanisms. They were redesigned. Initial hull configurations took on water in rough seas. They were modified. Tire inflation systems proved unreliable. They were strengthened. But these improvements occurred during production rather than delaying it. American factories produced DUKWs while simultaneously improving them, accepting that early vehicles would have limitations but getting capability into the field quickly. By late 1944, over 15,000 DUKWs had been produced. They operated on every front where American forces fought: Europe, the Pacific, North Africa, Italy. They had become essential to Allied logistics, moving supplies from ships to shore during every major amphibious operation since 1942. At Normandy alone, over 2,000 DUKWs had been employed, transporting thousands of tons of supplies daily across beaches, while German forces watched helplessly from defensive positions. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Germans attempted to develop countermeasures. Coastal defense units received training on targeting DUKWs during amphibious operations. Artillery crews were instructed to prioritize these vehicles, since destroying them would disrupt Allied logistics. Anti-tank weapons were positioned to cover likely landing beaches. But these measures proved largely ineffective. DUKWs were difficult targets. They moved quickly from water to land, dispersed widely rather than concentrating, and were replaced faster than they could be destroyed. For every DUKW destroyed, 2 more appeared. The American production capacity simply overwhelmed German defensive efforts. Some captured DUKWs were pressed into German service. Coastal defense units used them for transporting supplies between islands and fortified positions. The vehicles proved as reliable for German soldiers as they had been for Americans. Wehrmacht mechanics reported that maintenance was straightforward, using standard tools and basic skills. Parts from other American trucks often fit the DUKW since it shared components with the GMC family. Fuel consumption was reasonable given the vehicle's weight and our capability. Operational availability remained high even under harsh conditions and irregular maintenance. Obergefreiter Weber, who had first examined the captured DUKW in September, became his unit's resident expert on the vehicle. By December, he was training other mechanics on its maintenance and operation. He filed regular reports documenting his experience. One report from December 15, 1944, captured his assessment. This American vehicle demonstrates superior design philosophy. It is not engineered to perfection, but designed for practicality. Every component is accessible for maintenance. Standard tools suffice for all repairs. The hull construction is simple welded plate, crude by shipbuilding standards, but adequate for purpose. The drivetrain uses proven commercial components rather than military-specific parts. The result is a vehicle that works consistently, requires minimal specialized knowledge, and can be maintained by ordinary soldiers. This is the American advantage: they build equipment their average soldier can operate and maintain effectively. Weber's observations echoed findings from other fronts. German units that captured American equipment consistently reported similar patterns. American vehicles were simpler, more reliable, and easier to maintain than German equivalents. They sacrificed peak performance for consistent operation. They used proven technologies rather than pursuing cutting-edge innovations. They were designed assuming operators would be minimally trained, and maintenance would occur under difficult field conditions. This represented a fundamental philosophical difference. German military culture valued technical excellence and specialized expertise. Elite units received the best equipment and most intensive training. Support personnel were expected to be skilled craftsmen capable of complex maintenance. This approach produced formidable capabilities when everything functioned properly but created brittleness when conditions deteriorated. When skilled maintainers were killed or wounded, when supply lines were disrupted, when specialized parts became unavailable, German equipment performance degraded rapidly. American military culture valued standardization and simplicity. Equipment was designed so average soldiers could operate it adequately after brief training. Maintenance was simplified, so field mechanics could perform it with basic tools. Parts were standardized, so supplies from any source would fit any vehicle. This approach sacrificed peak capability for consistent reliability, creating a logistics system that functioned adequately even when conditions were far from ideal. The captured DUKWs also revealed American attitudes toward crew comfort and safety. The cab provided weather protection superior to open German vehicles. Heaters kept crews warm in winter. The suspension, while simple, provided acceptable ride quality. Visibility was excellent from the driver and commander positions. Emergency equipment including life preservers, fire extinguishers, and first aid supplies were stored in clearly marked, easily accessible locations. German vehicles often prioritized combat performance over crew considerations. Tanks were cramped and uncomfortable. Trucks lacked weather protection. Visibility was frequently compromised by armor or structural necessities. Crews were expected to endure discomfort as part of military service. The Americans apparently recognized that comfortable, rested crews performed better than exhausted, miserable ones. This wasn't softness but pragmatic acknowledgement of human factors in sustained operations. Major Hans Auerbach, an experienced logistics officer, visited the Den Helder testing facility in November. He had commanded supply operations during the invasion of France and later in Russia. His perspective on the DUKW was informed by years of struggling with Wehrmacht logistics inadequacies. His report to General Staff provided strategic context that transcended technical specifications. The DUKW represents American thinking at the operational level. They recognized that amphibious invasions would be central to their strategy. They are island hopping across the Pacific and invaded North Africa, Sicily, Italy, and France from the sea. They identified port capacity as a potential bottleneck. Conventional naval logistics assume you capture a functioning port, then use it to land supplies. But what if ports are destroyed or heavily defended? What if you want to land supplies across multiple beaches simultaneously to confuse defenders and distribute risk? Auerbach continued his analysis. The DUKW solves these problems elegantly. You don't need ports at all. Ships anchor offshore beyond coastal artillery range. They load DUKWs which drive directly to inland positions. No cranes, no docks, no rail connections required. The beach becomes your port, and you can use any beach along hundreds of kilometers of coastline. This flexibility makes coastal defense nearly impossible. We cannot fortify every beach, and they can land wherever we are weak. His conclusion was stark. We failed to develop this capability because we never asked the right questions. Our invasion strategy in 1939 through 1941 relied on land borders, surprise attacks, and rapid victory before logistics became constraining. We never planned for sustained amphibious operations across oceanic distances. The Americans and British planned exactly that from the beginning. They asked, how do we sustain forces after amphibious landings? And developed systematic solutions. We asked, how do we achieve rapid tactical victory? And ignored logistics until forced to confront the consequences. The strategic implications extended beyond amphibious operations. The DUKW's success demonstrated that specialized vehicles designed for specific purposes could provide advantages that general-purpose vehicles couldn't match. Germany had tried to minimize vehicle types to simplify logistics, the Kübelwagen for light transport, standard trucks for cargo, half-tracks for troop carriers, tanks for combat. This approach reduced production complexity but limited operational flexibility. America proliferated specialized designs jeeps for reconnaissance, cargo trucks in multiple sizes, amphibious vehicles for beach operations, tank transporters for moving armor, dedicated recovery vehicles, mobile workshops, and countless variants optimized for specific roles. This created production complexity, but provided tools precisely suited to their missions. The logistical system was designed to manage that complexity through standardization of components, thorough training, and abundant supplies. By January of 1945, German engineer teams had completed their analysis of captured DUKWs. The final reports ran to hundreds of pages detailing technical specifications, test results, operational assessments, and strategic implications. The conclusions were unanimous. The DUKW represented a significant American achievement that Germany could not replicate within relevant timeframes. The reports also documented a broader pattern. American military equipment generally showed the same characteristics: designed for mass production, built for reliability over performance, simplified for maintenance, and optimized for logistics. German equipment showed opposite characteristics: designed for peak performance, built with technical sophistication, complex in maintenance requirements, and logistically demanding. In short wars with limited geographic scope, German approaches had advantages. In prolonged wars across global distances, American approaches proved decisively superior. Some German officers recognized these lessons and attempted to apply them. Proposals were submitted for simplified vehicle designs, standardized components, and reliability-focused engineering. But by early 1945, Germany's industrial situation had deteriorated beyond recovery. Allied bombing had devastated production facilities. Raw material supplies had been cut off. Transportation networks were collapsing. Skilled workers were dead, wounded, or conscripted into last-ditch combat units. Germany could barely maintain existing production, much less implement new approaches. The final major combat test of captured DUKWs in German hands occurred during the Battle of the Bulge in December 1944. Several vehicles were used by Wehrmacht units for river crossings and supply transport. They performed as reliably for German crews as for Americans, but the larger offensive failed for reasons far beyond individual equipment capabilities. Germany lacked fuel, ammunition, reserves, and most critically, the industrial capacity to sustain operations against enemies who could replace loss faster than Germany could inflict them. As the Reich collapsed in early 1945, some captured DUKWs were destroyed by retreating German forces. Others were abandoned intact and recaptured by advancing Allies. A few survived the war in Wehrmacht hands and were returned to Allied control after surrender. The testing facility at Den Helder was captured by Canadian forces in May 1945. They found detailed German technical reports on captured American equipment, documentation of Germany's recognition that American industrial methods had proven superior. The post-war period brought opportunities for German engineers to formally study American manufacturing techniques. As part of reconstruction, German automotive and machinery industries were rebuilt with American assistance and guidance. Engineers who had examined the DUKW and other captured equipment during the war now had opportunities to visit American factories, study production methods, and implement similar approaches in rebuilt German facilities. The synthesis that emerged combined German precision engineering with American mass production efficiency. Companies like Mercedes-Benz, Volkswagen, and BMW adopted assembly line techniques, component standardization, and reliability-focused design while maintaining traditional German attention to quality. This hybrid approach would make German automotive and machinery industries globally competitive within 2 decades. The DUKW itself continued serving Allied militaries for decades after World War II. It saw combat in Korea, where its amphibious capabilities proved valuable for river crossings and coastal operations. It served in Vietnam for waterway transport. Modified versions operated in civilian roles, including tourism, rescue operations, and cargo transport in coastal or riverine environments. The last military DUKWs were retired in the late 1980s, ending a 40-year service life that testified to the design's fundamental soundness. Military vehicle designers worldwide studied the DUKW as a case study in successful specialized vehicle development. The Soviet Union developed several amphibious truck designs influenced by captured or observed DUKWs. France, Britain, and other nations created their own versions, each adapted to specific requirements, but following the basic concept, the Americans had proven viable. The lessons from the DUKW extended beyond military applications. The vehicle demonstrated that apparently contradictory requirements, land mobility and water operation, could be successfully integrated through thoughtful engineering. It showed that specialized vehicles, designed for specific problems, could provide capabilities no general-purpose vehicle could match. It proved that rapid development and production were possible when designers prioritized practical effectiveness over theoretical perfection. For Wehrmacht mechanics and engineers who had examined captured DUKWs, the experience contributed to a broader education in American industrial methods. They had seen how American equipment was designed for manufacture, maintained for reliability, and employed for sustained operations. These observations informed their post-war work, rebuilding German industry. The humility forced by defeat, combined with knowledge gained from studying Victor's methods, created a foundation for Germany's remarkable economic recovery. Hauptmann Richter, who had first observed DUKW's landing on Dutch beaches in September 1944, survived the war and worked in post-war German automotive industry. In a 1967 interview, he reflected on his wartime experiences. When we captured that first DUKW, we initially viewed it as simply another piece of enemy equipment to evaluate, but it became something more a window into American thinking about warfare, logistics, and industrial production. We Germans had assumed our technical sophistication would overcome American industrial capacity. The DUKW and vehicles like it demonstrated that practical effectiveness mattered more than theoretical superiority. It was a lesson we learned slowly and painfully, but one that served Germany well in reconstruction. Obergefreiter Weber, the mechanic who had become his unit's DUKW expert, also survived and found work in post-war manufacturing. His expertise in American equipment maintenance made him valuable to companies adopting American production methods. In later years, he contributed to training programs teaching mechanics about standardization, simplification, and reliability-focused maintenance. The knowledge forced upon him by wartime necessity became the foundation for a successful civilian career. The story of German engineers examining captured DUKWs represents a larger narrative about World War II, how industrial capacity and logistics determined outcomes as much as tactical brilliance or individual courage. The Germans had excellent soldiers, capable officers, and sophisticated equipment, but they lacked the industrial foundation necessary to sustain total war against enemies who could outproduce them in every category of military equipment. The DUKW wasn't the weapon that won the war. No single weapon or vehicle was, but it symbolized the American approach that did win. Identify specific problems, design practical solutions, produce them in quantity, and employ them systematically, not pursuing perfection but delivering adequacy in overwhelming volume, not emphasizing peak performance but ensuring consistent reliability, not building the best individual vehicles but creating the most effective overall system. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.